Okay, what we have here is 13.56 million cycles per second, and you're running about 150 volts RF output here. We're using a 10-to-1 scope probe. It's a BK, and we've got the setting down here. It's 2 volt division times 10, so you're talking 20 volts per division here. So we're talking 150 volts. We are pulling, that's 23.4 milliamps, and we're running 403 volts out of a EL84 tube. It's in the black box. We got the monster in the black box. The reason the monster's in a black box, and rather than on the plastic prototyping board where it started out life as Frankenstein, is because this thing cooks your brain here, and this thing is running, that's the load cell, over 100 degrees Fahrenheit after about 10 minutes. And we're running, it's about 148 volt AC RF output. We're looking at about 10.34 watts input and about 4.3 watts RF output. And efficiency is about 42%. So what we got here, this is the circuit. It's an EL84. We've got a tank circuit here. This one can't be tuned yet. We'll show you that in a minute. And this was it started out life as a parasitic filter, a coil and a 100 ohm resistor. That was tuned about 13.8 megs. Well, we replaced that with an adjustable tank circuit. Radio frequency capacitor here. R2 is, that's 2K, 5 watts. And I'll show you some of the values here. Anyhow, we have this basically a modified Pierce circuit. We're feeding positive feedback through the plate capacitor here to block the DC coming backwards. Tank giving us positive feedback here. Crystal over here. Resistor. This is kind of a different setup here. Generally, you don't have this in a Pierce. Radio frequency choke going to it's 470 ohm resistor. Bypass capacitor over here. We get the load cell over here. It's a 5K load cell. 25 watts. So values, these are the values of the capacitors and resistors. You found out if we're just running the function generator to try to get this kind of output that just didn't put the didn't enough oomph from the function generator, so we had to have the tank circuits actually providing the flywheel effect. Very simple. This crystal is 13.56 megahertz. In fact, that part number was, where is that part number? Here it is. It's the AS-13.56 MAHE-B. You get this at DigiKey for 25 cents a piece. It's actually a crystal they use in the digital circuits. I don't think it was designed for vacuum tubes. Usually vacuum tube uses a lot bigger tube. So anyhow, we're going to shut the monster off here. Oh, again, the reason we're running circuit in the cage, because you're getting RF heating whenever you're running this kind of power, this kind of frequency. After running this thing at, I pushed this tube, it's EL84. I pushed this tube to originally I was running 22 watts of input power into that tube, running 18 watts of RF output, and running from 10 to 18 watts depending on the my setup here. But after about 10 minutes of sitting in front of this thing, my eyesight started to get some artifacts around the edges, and I realized that I went too far. So I would definitely recommend any RF experiments, even if it's down to 5 watts, to put it in the box. Preferably aluminum, because steel has a tendency to interact with your coils and stuff. But either way, in a metal box. This is the capacitor, or the tank circuit here. It's got a inside here. It's got a adjustable capacitor. It was 15 picofarads. So the coil, this is number 20 wire, 17 turns. This is a 1/2 inch PVC tube from water sprinkler. This is just a coupler here. So piece of plexiglass here, and then the capacitor bolts into here, and then we connect it inside here with the parallel. But you want to tune this on a function generator with a 10K resistor, and then the scope to get the resonant frequency. Make sure you're right in the middle of the throw of the capacitor, so you can tune it positive or up or down on the frequency when you're done. Middle, you want to tune at 13.56, so you have a little room to play with. This is the original one here. We've got 2 in here. This is the non-adjustable. It's going to be replaced. We've got a 12 picofarad capacitor here, and we tune it by just having the right amount of turns on here. This was a 1.5 inch PVC, 8 turns on here versus 17 for a 1/2 inch. So you want to use a smaller one because you can get more turns, so you can fine tune that. It was really hard to do a full turn on this big of a pipe, so that's going to be replaced. Load cell, let's see if you can see that here. Not real. Let me get some light on the subject here. Let's see if I can turn it here. Here we go, a little bit. There's actually a thermometer inside here. It's a 25 watt resistor, wire wound. So it's hooked on the toolbox, grounding out one end. So that's what's putting the load on here. That was, where was that? That was R5 over here. So through a capacitor, this C7 was 12 picofarads. Same thing, we had 12 picofarads coming back from the tank over here. So 2 capacitors coming off of the plate, and then the this tank was in series with the RF choke up here. Anyhow, EL84 tube, we pushed that thing to the limit, burned that thing out. It was running about 56 milliamps, which was within the capabilities, but it was pushing out more. It's a 5.7 watt tube, and we were running 18 watts of RF out here, so it will do it, but probably for not more than 10 minutes or so. Right down over here we have, this is the terminal strip. This is the European style. You can put wires in here and tighten them down with the screws in here. The crystal is inside a little round circuit board from Radio Shack. Some of the other capacitors. So we did a lot of this was soldered in, and then we had run wires from here into the terminal strip. We got our power over here, and get the filament over here. And this is all temporary. Eventually this will all be soldered to the most of it will be soldered to the tubes, and then we're also waiting for some sockets, tube sockets, the octal 8 tube socket's going to be glued on here and solder the wires. Two wires come from the coils, and then we'll have this plug into a tube socket. So all these, just like the ham radio operators that build their own stuff, they use plug-in coils to change frequencies. So these will both have plug-in and a little more streamlined. Most everything will be soldered in here in the future. But anyhow, you want to keep your RF projects in the box. Keep the monster in the box, or your eyesight's gonna suffer, and you'll be cooking your brain. So there you have it.